update it later in the day. So whatever you get it later today. I'll update it as fresh as deck. All right, so I assume that we would have some. Oh, I'm sorry.
Just moves pretty quick.
It's good. SQL March 13.
Thank you.
I need to. Yeah, or you can just download it right there. Let me mute the speaker here. How do I do that? Yeah. So I assume some basic familiarity with availability groups. We're not going to spend a lot of time on. Sorry. I have it on live screen instead of at the end that goes through. I'm walking again. But I put this deck together from kind of my viewpoint, working in support engineering, both premier field engineering and as a dedicated support engineer for a few customers, kind of what we've seen in terms of SQL Server availability groups. So we're going to cover that from what happened in 2012, what they were about, what are the kind of investments we've made in the product from 2014 to 16 and 17 and so on. And I don't have it in here, but I should mention that AGs underpin the SLA guarantees we give for Azure SQL Database, especially if you're on premium storage today. If you're Azure SQL Database, come see me afterwards. I can tell you how to connect to those. It's in private preview right now, but we can send that out. You can connect to free scale availability replicas out there in Azure SQL Database. And then I think it's important to talk about a little bit of log internals, because those are really how we move data around, right? So this is not replication, right? That's something we struggled a little bit at the beginning. People are like, well, it's just replication, right? So you're just replicating stuff, or good experience. No, it's not. A lot of things have changed in that regard. So in order to understand how we move data around, I want to talk a little bit about log internals, the write-ahead logging protocol in SQL Server, which means you write the log first. This guarantees two things: the ACID properties, atomicity, and durability. Then we'll talk about the logbox behavior, because this is specifically something Julie asked. What happens if my secondary goes down? What happens if my primary goes down? What takes place? And now, I can tell you that it doesn't always work perfectly. So understanding how it's supposed to work is helpful for troubleshooting problems. And then finally, we'll talk through some common support scenarios, troubleshooting. Hopefully we'll hit some of that. I have like 20 scripts that I kind of use in my toolbox, but we'll walk through our troubleshooting methodology. If we get an AG case, what we look at, first three things, how to look at those. And then at the end, I have some self-study and lab resources, really a couple things. Okay. All right, sound good? And please interject or ask questions. I would rather do that. So from an HADR perspective at Microsoft and SQL Server, we have a lot of different things we can do. We're going to be talking about the first pillar here in the AGs, but without failover clustering, which if you understand, failover clustering is HADR at an instance level, whereas availability groups, it's a per database level or a groups of database levels. And that's an important kind of distinction to make. We also have database mirroring, which deprecated, still works. We replaced it with standard or basic availability groups in 2016. Which I'll talk about a little bit. We have replication. Some folks use it for HADR. Can. Log shipping, which is one of my favorites. It's been around forever. I can tell you I've never gotten a log shipping case. You combine log shipping with both AGs. And then we have backup to Azure and Azure Site Recovery, which is more orchestration around VMs and stuff like that. So moving on. Sounds like most through is pretty familiar, but if you're not, what's an availability group? It exists as it is a Windows Server failover cluster resource group, first off. We're going to talk about in 2017. We've disconnected a little bit from the Windows Server failover cluster, but I'm going to assume who's using 2017 Linux availability groups? Cluster list availability groups. Okay. Don't need to spend too much time there. Okay.
Feel free to go over.
I'll try.
What's that?
Free to go over though. Over? Okay. Right. I do talk fast. I apologize. I get pretty excited about SQL Server. So yeah, an AG is built on top of Windows Server failover clustering. Windows Server failover clustering is a cluster provider and this is a role you can install on Windows servers. It provides quorum, so it also hosts resources and does other things beyond that. But when you create an AG in Windows Server Failover Cluster, you get a single resource in there. It's our listener, essentially. But we also, within that concept, decide quorum. So we have this concept of primary and secondary replicas. Actually, I'll start looking at this screen here. So let me speak in the microphone. So we have primary replica, which is going to be a unit of high availability, right? That's our AG on a primary replica. You can have one or many availability groups. There is a limit to how many you want to have. You can run into things like thread starvation. We have a customer with 800 availability groups. They have significant issues, you might imagine, on one instance. But yeah, so within that unit of availability, you have a group of databases. Going to be one or many databases that fail over the unit between the primary and secondary replicas. A replica, we're just getting the terminology out there, it's hosted by a SQL Server instance, whereas a failover cluster instance is a single instance of SQL. A replica that fails back and forth between the nodes in a cluster. A replica in an AG is an instance on its own. So the next part of this is, we're talking about replicas. So what's a replica? Each replica hosts a copy of the database in its availability group. So in this case, we have a 2-node AG. Each replica would have a copy of that database. The active replica is called the primary. Second, any other replica in there is called the secondary. Right? Pretty basic stuff. Secondary can have one of the three following properties. It can be readable, non-readable. Readable means anybody can connect to it. And by the way, anybody can connect to this thing, connect right into it. Or it can have read intent only. Read intent only means that within your connection string, you must have a parameter passed through that says application intent equals read only. We make no determinations within your connection string to say, you can't do this DML or DDL, it'll just fail. This is a read-only copy of a database, not meant to be a competitor to RAC or anything like that. It's not a peer-to-peer application. Everyone probably understands this, used AGs. All right, so next. 2012. This is my one slide on 2012. So this is kind of the beginning. So again, we're going to talk through kind of where we're at. So we fail over from one SQL server to another, up to 4 secondaries. So 4 secondaries means how many total replicas? Tell me, anybody want a gold star? So if you could have 4 secondaries in 2012, how many total replicas could you have? 5. This will come into play when we start doing DAG math later, distributed availability groups. 27 replicas, 34 replicas. In 2012, it depends on Windows clustering in 2012. And you can connect to the primary, like I said, or the secondaries are read-only. Connect to them directly, or you can use a concept called a listener, which is a DNS object that lives as a Windows Server failover cluster resource that will point, that hosts a name and an IP address that will point to your primary or active replica. You do not have to use listeners. I have customers that have chosen not to do that. You can use something like an F5 or some of these other load balancers have plugins. F5, Citrix has them, NetScaler, WebScaler, whatever it's called, right? You can have automatic or manual failovers. Automatic's going to kind of talk through how that works, but you can have, do that for any kind of software, hardware, network problems you might have, as well as manual for patching or upgrade, or manual for recovery with some kind of, massive blowout. So we replicate transactions from primaries and secondaries. I'm going to talk quite a bit more detail on how we do that. This is a big point, and it can be a downfall or downside of AGs. So failover cluster instance, use shared storage, right? It's the same data files. Let's say you have a 10 terabyte database, you want to have 2 replicas, now you're 20 terabytes, 4 replicas, so on. The math adds up. Storage is cheaper, but it still gets pretty expensive when you're talking about these 40 and 50 terabyte SANs, and your SAN people can get kind of cranky. So you want to think about this in concept of you have an instance with this many databases on it, you have to do the math to figure out, my databases and my availability groups, you have to multiply that by how many replicas you want. so certainly something to consider. You can have synchronous or asynchronous. I'll talk about how that works. But generally, synchronous is going to be guarantee that no data loss, and we'll talk about how. Whereas asynchronous, you'd have the potential for data loss depending on the speed, right, of how you send those log blocks across. You can use that for read scale out or in remote regions. You want to have like a DR, a popular kind of architecture, kind of the reference architecture from 2012 was to have, you wanted an HADR, 3-node AG. You would have your 2 synchronous nodes on premises and your 1 asynchronous node, offsite in another data center or in Azure or whatever. Any questions on that? Tracking. This is all old news. All right. So what happened in 2014? A lot of things happened in 2014. Between 2012 and 2014, we had a lot of adoption. It is absolutely critical, and I don't imagine why, but that you be on the latest service packs, and I have some of the links here in CUs. There were a number of issues that occurred between 2012 and 2014, specifically around a concept called the log pool. I'll talk about that a little bit. So a lot of things happened from the support side that led to us having a goal. And why we could increase this to 8 replicas was we had the transports were cleaned up. The amount of threads we had to instantiate to do 1 log block send went from like 18 to 8. A lot of internal stuff, little tweaks, and the goal is for AGs, the stated goal, if you talk to the PMs, is not, a little bit less person than the primary, it's equal person. Because we rely on this log block transport for so heavily in Azure, all those internal unfinished are there to guarantee our SLAs. There's an enormous amount of investment on tuning and cleaning this up. So yeah, less than 2% of performance impact. So the secondaries went from 4 to 8, so that means how many replicas total? 9. So you don't want to do that. Another kind of unforeseen thing that happened, and there was a lot of complaining that came out in the Stack Overflow blog. But if a secondary were initially in 2012, secondary disconnect, a read-only secondary disconnect from the primary, you would think that you'd still be able to connect to read from it. That was not the case. That is the case now. So kind of a little side note. In 2014, I think I said this was in 2016 or 2012. It's not true. We allowed to do replicas to an Azure VM, so that's an IaaS VM. You can't add a PaaS SQL database today. Manage systems coming. You might see something around that. So I have detailed slides on this, although I just put this up just to kind of sum up again the amount of investments we're putting in this thing. 2016 saw probably the biggest changes in availability. So I'll go through each one of these one by one.
Your question. So
yeah.
Is this going to be available in DBAS and IaaS?
I'm not sure what that means.
Like in MS PaaS? So database as a service or infrastructure as a service?
Yeah. So you can add an IaaS VM as a replica, yes, in Azure, but PaaS SQL database, no. A managed instance SQL database, not today. That's the answer. But when I talk about how Azure uses this as its underpinning, it's a separate kind of product, but the log transport is still, when we talk about that, still there in Azure. So 3 automatic failover replicas, starting in 2012 and 2014, you can have 1 only. So we connect to the listener as before, as you can see here. If your replica 1 goes down, we'll connect to the second synchronous failover, connect to the third one, will become primary. If you lose 3, you're out of luck. Right? Not much we can do for you in that case. What's different about this is that you might have heard of something like the read-only routing list. Have you heard of that? The order in which we connect to synchronous replicas is determined by the preferred owner's order and failover cluster manager. So if you're familiar with failover cluster manager, set your preferred node order for like a traditional instance. You have multiple nodes owning that's capable of owning this. This is how you define that. This is a little bit different from a management standpoint. Another new thing, I didn't really talk about how we do failure conditions, but in SQL Server, use my laser pointer or not, but right, you can barely make that out. Oh yeah, there it is. Okay, so the failure condition level is something that we've always had prior to 2016. It's something called the flexible failover policy. It runs there's a stored procedure called SP Server Diagnostics. Anybody ever seen that running in like an SDQ2 or whatever? It's always running in the background. In this, I'll show you what it actually instantiates, but it had various levels you could set your various condition levels on. The default was 3, but you could also do things like number 5 to make it super sensitive. So you even had a query error, it would fail it over. But it would fail over, if you had a database go down inside of an availability group, we wouldn't fail over the whole availability group. It was only if the AG was down or the primary was down that we would fail over. Now, we have database failover level conditions you can turn on. If you have a database in an AG that fails for whatever reason, loses the file. I think I have it here. Lose the log file in this example. It'll fail over the entire AG with it. So a useful bit of tweaking. GMSA. So who here changes their service account for SQL Server on a monthly basis like you're supposed to do? Everybody?
We're implementing GMSAs.
Yeah. Okay. So GMSA support for AGs has not been there until 2016. That was a big deal for my customers. We went through that with them last year. You do require in your directory to have one Windows Server 2012 R2 DC support GMSAs with availability groups. Okay. So if anybody's not familiar with those, essentially these are group managed service accounts. You don't have to manage the password. We do all the password rotations for you in the background, right? Kind of a nice, management piece. And we partially started to support distributed transactions. So who uses DTCs? Is anybody blocked on availability groups because they needed DTC support? Or did you run into that before? No. So I had a customer that was blocked on this. Couldn't do it. We further enhanced this in 2017 as well. So essentially, we couldn't guarantee that a transaction's life would be atomic should the primary fail over that time. Now we have cancellation on that redirect fail. Okay. This requires that the OS and a patch link it up, will register those databases to DTC and it'll handle it. So this was a cooperative effort between the Windows product group and SQL product group. So this is a long time coming. But essentially, if folks aren't familiar with distributed transactions, where you have multiple back-end databases, you need to have some sort of guarantee of atomicity across multiple relational databases. You can use DTC to coordinate all that. So before the replica went down, we couldn't do anything about it, and now we can actually redirect you over to the second. Much higher synchronization throughput. Now I have some very detailed thread slides on this we may or may not look at, but this was a big deal. This goes back to that, how do we guarantee that super fast, throughput? A lot of things happen here. If you're familiar with database internals, anybody know what the log writer is? Okay. So that was a single threaded process. This helps not only AGs, but all kinds of other stuff. Anybody know what redo is? Right? Out of the log, right? Those were all single threaded. Now we can have up to 1 thread per new node, up to 4. We also do log compression and decompression in a multi-threaded fashion. This was done single threaded before. What else? Multi-threaded log redo. We're going to hit all this in detail, and I'll kind of point you out before we were doing this, but the compression is pretty fast and good. But however, we do turn compression off for synchronous replicas because it was causing faster. You can opt in and out of that. But the throughput, as we can see, we had a customer, very large customer that was they were running into, they needed to actually put about 100 megabytes per second. We couldn't do more than about 50 in 2012. you can imagine probably this that was the kind of their low watermark, right? We went up to 500 megs per second after internal improvements. We think we can go even faster than that. All right. 2016, more enhancements. So replicas in different domains. This is in a distributed availability group, which I'm going to hit. But this is a you can have. This is again one of those cooperative efforts between SQL and Windows, where you can have Windows cluster across two domains. This is new. It requires Windows Server 2016 as well as Windows 2016. And we configure those relationships using certificates. Did anybody use mirroring? Yeah, so we got to, you remember, I don't know if you remember this, having to set up your certificates for all that stuff. It's been a while for me. And then we have this concept of distributed availability groups. And I could spend an hour and a half talking just about how to implement these. These are a little tricky. When we talk about the log sync transport mechanism, you'll understand that I have to send these log blocks not only to my primary, but to every secondary inside of my availability group. So if I have 8 secondaries, I could be sending these log blocks out. But let's say you had an AG here in the States, and you wanted to replicate that out to an AG in Europe or whatever. We can have distributed 2 availability groups, and we have a single stream going between 2 different primaries. You'll only have 1 master at a time. But pretty interesting implementation. Now, this was introduced in 2016. I haven't run into a lot of customers starting to use this yet because adoption isn't super quick for on-prem. This is starting to kind of roll out, and we had a conversation kind of prior to this. I'll be interested to hear any of your learnings around if you have struggles with that or whatnot. But I haven't seen too many support cases come out of this yet either, which tells me not a lot of people are starting to use it yet. But essentially, these are two separate Windows Server mails, but split the difference. But we're only having to send that log stream over once, and then it gets redistributed on secondary down to all the secondary primary, down to all the secondary. All right, load balancing of read workloads. Load balancing before didn't exist. So you had to use F5, WebScaler, whatever. You had read-only routing, which would, if your secondary replica wasn't available, we would go to the next one. That's been around since 2012. It was all configured in T-SQL. We have a GUI for it now. We can actually do some primitive, or it was kind of a naive implementation of load balancing where we just use round robin. We're looking at things like CPU utilization, stuff like that. But that's not out there right now. But essentially how that works is that within your read-only routing list, which you can specify when you create your AG, in this example, you can see we have 2 sort of sub-parentheses. So we have, let's imagine that our DR site is replica 5, so we wouldn't want to round robin over that. We set up a group of these 3 replicas here. These are clients. These 3 replicas here in this first group. So we're gonna go replica 1, 2, or we're gonna go 2, 3, 4 for read only. And should they become unavailable, we'll go to 5. You can kind of see how the semantics work there. Right, so we have that kind of animated 1, 2, 3, 1, 2, 3. So that's round robin. All 3 go down. Boom. Go over to replica 5. Does that kind of make sense? Essentially just load balance here across the locals, and if those are unavailable, we'll go remote. Automatic seeding. All right, so those of you that have implemented, you like automatic seeding. You may not like automatic seeding. Depends on how big it is. How big are your databases?
For the ones that we have automatic seeding, they were smaller.
Yeah.
50 to 100K.
Good news is that automatic seeding uses all this, all the internal improvements we have. So that's a good thing. But there are things that happen in terms of log truncation that can occur. But I gave you tools to look at that at the end. I love automatic seeding, but folks need to go understand how it works and kind of look at the process. It sounds like you've had discussed that. The really cool part of it is that you can have an availability group, create a database inside of it, and automatically gets pushed out to all the other AGs. That wasn't something you had to do manually. So automatic seeding, prior to 2016. Go ahead, Julie. Will it work on large databases? how large is your database? No. Yeah, I mean, I wouldn't do it. It really 17 terabyte database. Uh, you have to quiesce all database traffic, right? Because we don't do log truncation and other stuff. This is really one of those things. I mean, large databases, how often are you setting this up? This is for ISVs. This is for companies that have AGs that have smaller databases in them. Maybe they're adding. A perfect example is I worked with a real estate company, and they had AGs set up like this. And every time they brought a new customer on, created 3 new databases for them. Like, okay, every time we do this, you have to set up, you have to add these databases to AG, set up all this stuff. You would have to back up and restore the database, back up to the log, join them up. Now it's just because, I'll show you kind of how this works, but now you can just add it to the AG and it automatically gets pushed out. That's kind of what it's for. I would not use it for 17 terabyte database. Yeah. Yeah. Once you get close enough, I'll talk about how the log pool works. You don't have to get exact. If you can get inside the window of the log sequences that we store in your log pool, it'll pick it up. So yeah, I love automatic seeding, but I always get that question, oh great, so I'll have to back up my 17 terabyte database. No, still going to want to do that. Automatic seeding solves some other problems. Like I discussed. Any other questions around that? Sounds like we have one successful use case. I'm glad to hear it. Awesome. I'm excited when people are just using SQL 2016. I've been supporting 28, 2008, 2012, and other things for a long time. Basic availability groups, what's this about? Has a lot of limitations that you might see. What this is a replacement for database mirroring. It works as standard. I should mention that all these things I'm talking about today are enterprise edition. The AG stuff I'm talking about. If you want basic availability groups, you get that in standard, non-readable. It's essentially one database per AG. It is a one-to-one feature replacement for database mirroring. But database mirroring is still there, but it doesn't have all the investments we've made in speed and other things that have come along with AG. All right, we're almost through the features. We've got one more slide.
So if you just needed a primary and secondary, you only have one database.
One database. You can have multiple AGs, though. Yeah. One day you would have to create one AG per database. Yeah. Database mirroring has some limitations. All the stuff that you have here, like for example, our supporting database mirroring, like for example, cold storage, because we rely on snapshot isolation level on the covers. So there are reasons if you have database mirroring today to move to this, because of the support we have and other things. But yeah, it's limited.
Well, the clarification, you said you have it at 180 per database. It's like, I thought, for instance, there was only in standard, only one data, not that you have set up different.
Oh, you can have multiple AGs.
Okay.
But it's just kind of a management. And the other thing is, it's a big benefit, a reason why AG starts to come out, if you want groups of databases to behave together, right? Because their applications depend on cross-database or whatever, cross-database join. So yeah, it really is just supposed to be kind of a one-to-one thing with mirroring. Does that make sense? What else? Not readable is another thing too. So that's the other big advantage of obviously availability groups is the readable secondaries. All right, 17, and we're gonna skip over to a few demos here. All right, so 17, we're gonna throw a few more wrenches at you, and I'm kind of gonna stop here because we have support on Linux, for example, clusterless availability groups, which are manual or cross-platform availability groups. Windows and Linux, and I can tell you we have a customer in Dallas that did this in production last fall successfully. It is not there to be a long-term solution. It's for migration purposes. All right, you have your Windows AG, you want to move to your Linux AG. This is Linux shop. They had Windows 4 SQL Server only. The other thing that's kind of important is full DTC and cross-database support. Those two didn't really come together. We had DTC support, but not cross-database plus DTC in 2016. There is an option here called required synchronized secondaries to commit. You can select up to 2 or 3 secondaries that are synchronized to have actual committal before you send a commit back to the client. In 2016, we would only have to have 1. And you have in Linux only something called a configuration only replica, which can be a third replica joined to your availability group, but only has configuration data. So think of this as almost like the witness in Berry. This is for customers that want to have high availability and disaster recovery in Linux, but don't necessarily want to have 3 SQL Server class machines. They can have a third machine that's configuration only and helps broker that quant. And then, last but not least, we have 3 different kinds of cluster types we support. Windows Server Failover cluster, which is traditional, external, so it's going to be Pacemaker or CoroSync in Linux, or none. You can do that in Windows. So now you can just be like, hey, I don't even want to deal with clustering. I just want a bunch of secondaries out there for read scale. You can just set that up and just blast these secondaries out and use them that way. But there's no automatic failover. It's not an HA solution for read scale. All right, so we're done. Features. Where are we at? We're basic. Sorry. Yeah. Sorry. All right, so automatic seeding, Management Studio 2017, a few different features. So let me duplicate my screen, and then I'm going to have to reshare. I'm going to freak out. You guys want to tell me if I'm resharing? I don't know. Do we have people on the phone?
Yeah, we're good.
Okay. All right, so let's just walk you through a couple things. So if you've used AGs before, those of you that have done it before, I want to encourage you to start using Management Studio 17 Plus. You might have noticed that Management Studio got disconnected, just like reporting services got disconnected from the SQL installer. And because of that, we're making, every couple months, big investments in Management Studio. Part of those are some of the wizard things and other dashboards and reports that we have there to support AGs. So if I wanted to actually create an availability group here, to go to an availability group wizard, I'm not going to go through this whole thing, but I'll show you some of the new stuff. So we have, I can call my availability group something, AG. We also have per database DTC support, and you can turn on database health level detection. That's that thing I talked about where if there's a database problem, we'll fail over the whole AG. You can also specify your cluster types, which is all new. This is what was there before as the default option. It wasn't even presented to you. But external would be what you do for a Linux AG and none for read scale only. Can I zoom? I can't hear you, Julie. Sorry. I can't. I can do like a whole zoom it thing. You want to do that? This is nothing changed here, so we'll just choose this one. I'm actually going to go to a script mode to do this. But I want to show you some new options here just on this screen. Add your replicas. Put that in a couple here. Okay. A few different options you can see that might have been new to you. This required synchronized secondaries to commit. Whether or not they're readable, this is all new, all the same, right? Yes, read intent only. The read-only routing. Did anybody implement read-only routing before? You would have had to do this all through a script, and we provided scripts to that, but this is all now a first-class notion in the GUI. Listener backup preferences, that's all the same. I just want to kind of show you some of that. I will want to cancel this. Yes. All right. Now here, I'm going to zoom in on this. Here's the output of that wizard, essentially. I'm going to go ahead and do this in SQL command mode, but I'm going to show you how the automatic seeding works. This is all standard. My endpoints are started up. Then we'll go through and actually join my AGs, but you'll notice there's a big step that's missing in here. I'm not backing up any of these things and storing them. So you would have had to back this up and have these ready to go in recovery mode. I'm adding in this option here of seeding mode equals automatic. Right? That's the piece there that's going to have that automatic thing. Now, there's another piece to that. I have to warn you. If you choose automatic seeding mode in the GUI and then click script, it leaves a little detail here out at the end, and you have to actually, for each replica, grant the availability group grant it create any database. Right, so alter AG, grant create any database. That's kind of a missing piece. All right, so let's actually create this whole AG here now. That looks like it was successful. And then we have some DMVs to actually have you watch. This is a very small database, so it happens quickly. We have DMVs here. Sys.dm HIDR automatic seeding automatic seeding, I should say. That'll give you the state of the seeding for each one of these. And these will all be seeded up because it's a very small database. But I can just show you what that looks like across the three. So if there were any issues you might see in here, what your current state was, that's going to be completed or in process. That's not great. If you need to get more detail, there are X events around this. So if you're going to do manage events, actually, maybe in my debug channel. Yeah, so in the debug channel, there's a number of, if you're not familiar with this, if you go to create an X event, the debug channel is not going to be on by default, but there are all kinds of, events you can add in here to look for more detail. So this would be for your large databases. If you want something better than in progress and completed, this is where you're going to go. You're going to have this turned on ahead of time. Yeah, so that's pretty much it from a Management Studio perspective. I just wanted to show you some of those things. We're going to come back to this because there are some new things around the reports and so on. But we will switch back over and start talking about some of the log transport stuff. So again, I'm not spending a lot of time creating AGs because pretty much the entire room raised their hand when they said, yeah, they've used AGs. So we're not going to belabor that point. Let me move that to my extend. Oh, yeah. I'm going to share my other screen again. Share monitor 2. Not sure what's up with that. What are you seeing over there, Sean? Am I seeing full screen or what?
I see your. I think we're good.
Okay.
It's got a weird box around it, but I can still see the whole slide.
Okay. Sorry about that. I'm not in Skype. All right. So we're going to talk through some data synchronization internals. Hopefully this will help you understand, where things are going wrong if they do go wrong. Essentially how we send log blocks, what a log block is. Everybody familiar with the transactional log? I would assume that it's the basic level what log blocks are, log records are, log buffer, log pool. Then we'll cover some of these scenarios that Julie specifically asked for and didn't ask me for upgrades at all. Or else I would put that in. We'll talk about that later. But what happens when the primary goes offline? And what happens when the secondary goes offline? After you learn this log transport stuff. All right. So, but to talk about availability groups, we have to talk about transaction log internals. So everybody's familiar with transaction log. Typically, it's the LDF, right? Captures all the changes that occur in the database. You insert a record, you update a record, you add an index, you add a file, everything. You re-index or you rebuild an index. You change any physical structure. We capture that in the index or in the log. Changes mostly occur there first, and then later are persisted as data files. So this is what enables that. This is why you want to have your log file on a different drive than your data file for that write-ahead logging protocol. That enables durability. It also enables something called atomicity, because if you start an explicit transaction, we will begin to record all of your log records, and then when you commit that transaction or roll back that transaction, we either have to do all of those things together as a group, or roll them all back as a group. Think about the classic atomicity example is an ATM in a bank. I go to the ATM, I ask for $20. I have to both get $20 out of the ATM and have my account debited $20 in order for that transaction to be complete. So that's the concept of atomicity. And that's what this log guarantees. I say mostly. Bulk chain or bulk log protocol, due to the way the semantics work, we have to actually be writing to the data file at the same time we're writing to the log file. That's a different. That's the one kind of exclusion here. To write to and read from them sequentially, you only need one of these. Memory optimized table logging, very different. Very different. Depends on who's writing the slide. Because we don't log anywhere near these things in memory optimized tables, like no index. But we still write there first.
What's a log block?
What's a log block, and why do we care about log blocks? This blue box here on the right is what you're sending around in availability groups, right? This is the atomic unit of the physical commit to the log. Logical unit is the record. Next one, the atomic unit. We will have the header, which will end up with records counted, what the block size is. It can be anywhere from 512 bytes to 60K. And if you're familiar with page internals at all, it has the same kind of slot array with twice the offset within the block of the log record that tells you where that record is, right? So no need to get too wound up on this, but this is essentially the unit that we're sending around, because this is the physical unit of change in the log. Here's another important part if you're thinking about even I/O in a log. People want to know, what should I set my I/O to? My log files, well, we can do a write from 712 bytes to 60K, right? Actually 64K when you include the header. The log record is what contains the LSN, right? The log sequence number. Everybody's seen this around, right? So this is the atomic database change. We not only have committed transactions, we have stuff around redo or undo a transaction, and we have these log records, irrespective of if you're in bulk logged or simple or full recovery mode. All right, now I apologize. I have to stand. I'm gonna have to walk around this. I had this animated, and for some reason, see, it's happening. Pause. Oh, that's awful. Damn. All right, I give up. I'm gonna drag this over here. I'm not sure what happened to my animation. It went wonky on me this morning, and it was playing through the entire thing. All right, so this is an important concept to understand. And I have to walk away from the microphone, so those of you on the phone, I apologize. But each one of these buffers represent log blocks and log buffers on the earlier slide. So when we start writing, we start having a lot of you have to limit these buffers to the number we might have. Once a buffer starts filling it up, once you get the max size, okay, let's say on this current buffer, we get the max size. That's this background log writer. We signal that background log writer now. Using log writer. It's waiting to get a signal on it. Okay, I'm going to take the full buffer, and I'm going to flex down the part. Okay, two places. The transaction log will be also go to the log full. Sorry, earlier. So this write log is probably one of the most common types you see out there. Time between my current buffer and signal log writer and that actual write occurs is where we accumulate write. Okay. Everybody understand that concept? Signal, we're ready to flush. Different ways we'll flush.
So let's say
Let's
this
take
signal
the signal and
allocate
allocate another buffer. Don't take a serial process parallel. Sorry, wait here. My second buffer is instantiated. We'll begin filling it up with log blocks.
Second way
We'll actually signal and transmit. We'll flush down. Well, okay. And then we'll allocate another buffer and so on. If you run out of the number of buffers, I'll actually allocate where we'll have to run into a log buffer. We see that. Two different kinds of third ways. There's two more possible. Yeah, this is kind of a very high level overview of how that's what these equators all mean. Questions on that? Does that make sense?
This is important
to understand because this is how we actually do log transport. I'm going to go back, and that's the only wonky slide that I had. And I will. Share monitor 2. All right. I don't know why it stayed that time.
So starting
in 2012,
this was
a huge change. Now, 2012 had a lot of changes internally. But this is a big change because we actually added this concept called the log pool. The reason why is because it started to have so many consumers with logs, FND logs, rollback, recovery, TDC, change data capture, replication.
all those
have to actually hit physical log files prior to 2012. We added this concept, and I showed you how the log writer thread was pushing things down to log. We also pushed things down to a log pool. And if you look in sys.demo as memory clerks, you'll see a log pool out there for database. And we kind of an enhancement in terms of the way we have to constantly go back. It keeps us from having to constantly go back to the well in terms of hitting the transaction log. We go to the log pool instead. The log pool, I put this KB down here to read about it, was one of the earlier struggles. You had to figure out how to balance that memory clerk against the other memory consumers, SQL server like the buffer pool and feature cache. We actually had instances where customers were filling this log pool up enough, and our internal trimming algorithms weren't aggressive enough. We were starting to push out the feature cache, buffer pool, and all the various negative effects. Heard about that. I'd like to put people with, that's been addressed in 6 years. But you can look at this, but essentially, we don't have to go to log pool and traverse the entire chain. We'll actually go through whatever else is looking for. We'll pass it through to a hash algorithm to match. You can look at some of the DMVs around that and so forth. So just a quick, that's where we're done with transaction log, but I wanted to kind of cover how that works. All right, so now that you understand all these pieces, right? You understand the log cache, log pool, all that stuff. These are the pieces that we covered here. Here. If you take AGs out of it, it's always happening. So transaction 1, the primary replica will generate some log blocks. At that point, secondary will initiate a request of the primary asking for those log blocks to be shipped. So all three of those things happen. I walked you through kind of how log internals work, but we started our transaction, we did an explicit commit. So at that point, we do our local harden and we push it to the log pool. So we have this log cache being filled with these log blocks. So when that log block becomes full, or we hit the explicit commit as we did in this transaction, then at that point we will signal essentially the log capture thread to begin sending these across. The log capture thread, there's one per replica. Why we talk about, and one per AG. Where we talk about things like thread starvation, there's a limit to the number of threads you can have in SQL server. Increase them. But so each secondary that connects up instantiates their own log capture thread and says, "Yep, I'm ready." So at that point, we start sending those across, and we will persist them in our secondary log cache. And at that point, we will push that to the T log. Now, what happens? So you can notice that during this entire process, we haven't acknowledged the commit back yet. So we do that now once it's hardened to the T log on the secondary. And then we tell the client, yeah, you're ready to go. Now, what's the big piece missing? It's on the data file. So I've acknowledged my commit back to my client on the primary. But if I were to do the exact same moment where that record changed, I would not see it. Right? And this is called a redo queue. It's called the redo process now has to take place. Now, redo occurs all the time. You push those into the redo thread, which will then persist those changes into the data file. That's an important concept to talk about, and it probably has caused a lot of consternation with customers. We've actually built some cool stuff and to actually trace this latency. So redo thread monitoring is absolutely critical for availability group performance. Anybody run into that using AGs, redo thread, Ewing, Justin, Julie? Okay. Yeah. Oh, yeah, ETL, yeah, sure. ETL, I see it all the time happening with people who are doing large index rebuilds too. Which, by the way, stop doing large index rebuilds. So we can talk about that tangent here at the end. Yeah. So any questions about that? Does that help? And by the way, you're going to get the slide, and there's copious notes for each one of these things that comes in internally. So you can go back and click through this and be like, yep, okay, this is the piece, this is the piece. So in 2016, I talked about all these log transport improvements. We had, parallel decompression and redo of logs. So there's a reason why I'm going to go through here. Let's say a redo thread could be doing this up to 4. If I had 4 NUMA nodes, and this does have to be a NUMA physical server, right? So if you're running this in an SMB server, you're not going to have this benefit. We assume you don't have that kind of throughput. And then we have the same thing on the primary side. We have the parallel compression and so forth. Optimized synchronization protocol. All this kind of comes into reducing the number of threads we need to have to actually make this change, do these changes. And the end state was that 50 megabyte per second to 500 megabyte per second throughput that we had. So what do I go to, 4? Okay. So data synchronization mode and asynchronous. The synchronization piece works exactly the same. The only thing that changes is when we acknowledge the commit back to your transaction, right? You can think about asynchronous. We don't care. All we care about is actually getting hardened locally. So provide the transaction, split the commit, log block and flush, log pool, and harden the C log, boom, we're done. We acknowledge commit right then. Okay? But at the same time, we do signal to the log capture thread to say, hey, you need to go ahead and send this over. So we'll send that through and so on. That works exactly the same way. I went through that pretty quick, but really the big difference there is when we actually send the commit back. Maybe news or not to anybody. I'm going to run through these next slides pretty quickly. I'm not going to go through every step. I'm going to give you this data to look at. Oops. I just want to count the number of threads per log block supply phase. This is all documented as well. But essentially, in 2012, we had about 14 threads per log block, and then going down to 11. Now, it doesn't sound like much, but if you are doing you're trying to kind of trim every little last nanosecond off of an operation, it makes a big difference. So a lot more lightweight in that regard. There are other changes too, in the way we do some log caching and other things, and the order in which this stuff is done. And rather than belabor this, I'll let you guys look through the notes. Right. So this is pretty interesting from that perspective. Because I want to get to some of the meat and potatoes of troubleshooting. So when the primary replicas, what happens when a secondary replica goes offline? This is probably a pretty common thing. Either a secondary replica is going to go offline all the time if, say, you're using a rolling patching, right? You're patching your secondary, you're failing things over, or it goes offline for some other reason. But it's probably going to be a pretty common occurrence in AG that the secondary goes offline. So what happens to the primary in that case? We hold those transaction log blocks, right? We will hold those in our log pool for as long as I can. And as I mentioned before, the log pool is governed by some internal algorithms in terms of how aggressively we have to trim it out. We don't want that log pool shares memory space with things like buffer pool to start, causing those to trim out themselves. We will also, most importantly, see the transaction log grow. Not only the primary, but every other secondary in the availability group. That's another one to think about as well. So fix the issue, you bring it back online, or the other quick fix, you have an emergency situation, transaction log growing everywhere, pull that secondary out. And that's what customers typically have to do in that case, kind of in a quick fix type scenario.
What about log backups have an effect on this? If the secondary's down, then you have a transaction log backup in the meantime. How does it handle the transaction? Truncate the log still or no?
No, does it? Yeah, that's a great question. So if you look in CBCC log info for any transaction log, if you can do this for yourself. Set up a 2-node AG. Take the secondary down, keep applying records to the primary, look at CBCC log info with an empty paren for that database, which will give you a record-based list of every virtual log file in DLF in that log, and it has a code. It has 2 different codes in it. Whether or not you can reuse that DLF, which is that log translation piece you're talking about, and why not? And the weight type you'll see there, both there and that database is Hadron. It'll be a Hadron type weight, which means HR is our internal name for HR. But we do not allow those to be truncated even though you back them up until they have been marked. Having been set. A good question. That's a little different from replication. Right, so if you're thinking about how that might work. All right, any other questions around that? We're actually going to walk through this in a graphical manner. So when our synchronous secondary replicate goes offline, so we have our primary and our secondary here. When you have a synchronous secondary replica, it's going to have a synchronization type or status of synchronized. I wish we had better names. We also have synchronizing. But we'll walk through what that means. So let's say our second synchronous replicate goes offline in this case. All right. Now we have a status of not synchronized. Okay, so now it's back online. What happens now? Well, obviously we haven't quiesced all traffic to primary. We still have changes occurring there, so all that stuff's happening. We're storing the log block, the log's getting bigger. So as soon as it comes back online, it says, hey, I'm back. So it'll establish that connection back with the primary replicate and sends the report part it sends is the EOL LSN. So end of log block sequence number. Hey, this is essentially, this is the last record I have. Let me tell you about it. So that's that first piece. And then at that point, the primary replica then starts sending the log blocks, any log blocks that it has hardened after that EOL LSN, right? We'll send those over. We'll begin hardening. We'll begin the redo process. And this will continue to occur kind of in a circular pattern and until we keep reporting back to the primary saying, okay, we're synchronizing. Remember, we're not synchronized yet. We're still synchronizing. Here's my last redone LSN. And then once I hit this piece, we keep this process going. Once my last hardened LSN of my primary and secondary match, then we go to this next piece of being synchronized. Right, so it's a pretty simple process. Hey, here's the last thing I got. Keep sending it to me, and I'm all right. Got that. Here's the last thing I got. All right, got that. Let me send it back. We repeat that process until we're now in synchronized mode. This isn't an ideal world, right? So maybe you've seen this go offline for extended periods of time, and there are alternate methods. So this is in a synchronous secondary replicate goes offline for a period of time that it can read from the log pool or whatever contained in the transaction log. I should mention that if the secondary goes offline for long enough, and we say, here's our EOL LSN, the first thing primary is going to do is look in the log pool, and it's not there. We'll go to the transaction log in that case. Right, so we'll keep backing that up. And it can catch up, but on an extremely busy database, this can also be, you can also maybe have more success in, it's kind of just doing a transaction log backup or whatever dip, which can kind of, get things more synced up. Does this sound like a familiar scenario to anybody? This news, anybody, or is this just like know it already? All right, so at that point, we start waiting on acknowledgement secondary. All right, so an asynchronous goes offline, a little bit different. in terms of, it's always, remember, we're in that synchronized state. You only get that with a synchronous replica. And asynchronous replica is always going to be asynchronizing, always. Because synchronized state only means that our last hardened LSN equals your last hardened LSN, primary and secondary. So the primary responds in the same way if the asynchronous goes offline. This is an important thing to note. Asynchronous goes offline can still impact your primary because we'll still keep those log records. Log files will grow. Logs will get bigger. So don't think you're just saying, oh, it's just asynchronous. You still need to be thinking about this stuff from a management standpoint. It'll be not synchronized at that point. It comes back online, same kind of thing. Sends its EOL LSN. We start replying back with transaction log blocks after our last hardened EOL LSN, and the same process occurs. But as soon as we get that state, I should say, as soon as we start, it's a little bit different. As soon as we start coming back up, we'll stay synchronizing, even though it could be way behind, like an hour or two behind. It's asynchronous, and there are other things you're going to have to look at: perf counters, internal DMPs, to say how far are we behind, what's our queue there, log send queue size, what records we need to send over, and so on. We'll cover those at the end. All right. So primary replica goes offline. What happens then? All right, so this is going to be that scenario where it either goes offline because you sent it over, or it goes down for other reasons. There are three different kinds of failover. So automatic failover without data loss. So this is if you have an automatic a failover target that has that role, a synchronized replica. Planned manual failover, or forced failover with possible data loss. Now, there is a scenario where I've got a bunch of secondaries. My primary went offline. Which ones should I force it to? Well, we can look at each one of those and see what the latest LSN was and force it over to the one that maybe will have the least amount of data loss. And I have a demo of it. So if you are in asynchronous commit mode, you can do forced failover. If you're in synchronous commit mode with manual failover mode, you can either do planned manual failover, which is right-clicking on Management Studio. By the way, never ever do a failover in availability groups using failover cluster manager. Everybody knows that. That's a big no-no. If you want to do this from within Management Studio, because we will actually do some guessing internally while we fail this stuff over. And then if you're in synchronous commit mode with automatic failover, we'll do it online. Automatically, I should say. And in 2016, as I showed before, you can do this database level failover thing. All right, so what are the conditions required for automatic failover? Well, you have to have them both set to synchronous commit, set to automatic. You have to synchronize the whatever cluster manager you're using. I say Windows Server failover cluster, but same with Pacemaker or Core Sync. It has to have quorum, and the primary rep is unavailable, and whatever condition levels have been met. So for whatever reason, let's say in an automatic failover scenario, let's say if we have a server instance that's hosting this primary replica, if it's still running, and that is, it didn't get the cord yanked out of the wall, we'll change the state of the primary database that's disconnected and disconnect all of our clients. That's why I say doing this thing gracefully. We'll try to restart our resource. We'll check our health. And if it fails at that point, so we do a little internal restarting, we'll actually flip the scenario over to one of our secondaries. So this is in a case of having two secondary replicas that are in synchronous mode. So let's say then when replica 1 then restarts at that point, it will go through and oops, I went too far. If replica 1 restarts at that point, it goes through and says, hey, I'm ready to start receiving, and it'll go through that same kind of process we looked at before, but it'll if it's behind, it'll request that log synchronization traffic, and once things line up, then it'll be back in synchronizing mode. Synchronized mode, I should say. All right, so for a manual failover, very similar. We can fail it over. We have to be set in synchronous commit mode. This is planned manual. This isn't a forced failover. You can do it a few different ways. You can do it with T-SQL, Ultra Availability Group, Group Name Failover, Management Studio, or PowerShell. And you can do it also with Azure Site Recovery, ASR, which is pretty interesting as well. you have kind of a hybrid scenario. Very similar to the automatic failover in that case. Forced failover, you have possible data loss, right? This is primarily for disaster recovery only if you need to failover to the asynchronous node. But after a forced failover, you have kind of a mess to deal with. You have all the secondary databases suspended. You have to join them back in or set up, however you want that to be. You have to manually resume each one of those. And also keep in mind that during this time, the T-log, any kind of truncation that might occur in the transaction log will be halted during this period. So again, you can do it through all the different ways, Management Studio, PowerShell, and so forth. Let me kind of show you how that works graphically. So here we have a 2-node AG in asynchronous commit mode. All right, so let's say we lose one. It's just down, right? So all we have at this point is one readable secondary replica. We have to actually issue a command here, and I say we perform a manual forced failover. That's, there's a command to do that. Alter database set failover, allow data loss, something like that. But the thing is that because there was traffic experience during the failover data movement, my former primary LSN is actually higher than my current LSN. So my current hard LSN on my now primary, because I forced that allowed data loss, is at 50. So what it does actually is that once you manually resume synchronization, it'll say, hey, I'm ahead of you. And at that point, it'll actually start doing the redo, or undo, I should say, which is another process that occurs in the transaction log. Roll back using my LSN, using my log records, because I have all those records in the log. I'll roll back all those changes back until my LSN matches up, and then we'll resume that data.
I'm sorry, did you say, are we manually cleaning the logs, or would we rejoin the now secondary?
Yeah, when you manually rejoin the now secondary, it does it'll do that redo. It'll do that undo process automatically.
Using the redo.
Yeah, right. Same thread. Works backwards and forwards. Yeah, there's nothing manual you have to do from that process. The only manual step you're doing here is you're resuming the synchronization essentially. All right. Am I tired of looking at slides? I'm tired of looking at slides. So let me switch over to duplicates. I just want to kind of show you a quick demo on how you do this. Again, this is on those scripts that you got. So I have my. All right, I have my AG already set up, which I did before, and I'm going to back my databases up real quick before I start this. Essentially what I'm going to do is just show you these scripts. I'm not going to take anything offline, but I'm going to show you the set of scripts that we use if we have customers that have this scenario to look at what is the latest LSN that has been applied or hardened in the log. And that can be, if you had an issue where you had one in New York, one in LA, and you're in St. Louis, it's like, okay, St. Louis just went down. Which one should we force our failover on? Just quick look up on what the latest LSN is, and that's going to be the answer for you, right? So quickly, I'm going to. Side note. Does everybody know this exists now? If exists. Create table if exists. Create procedure if exists. Drop if exists. That's a lot better than what the conditional case statements you used to have to do before. I'm going to start running a little workload in here. Nothing fancy. I'm going to do deal here. Table. Yeah. All right, so I'm going to start. I'm inserting just some basic values in, and let me do all this stuff over to command mode. All right, so really quickly to look at, you want to look at these DMVs, DM HADR database replica cluster states. we'll look at each one, and we'll connect to each one. Now, in this case, I'm connecting to one SQL node 1. So let's say SQL node 1 went down. You could still check at this stuff on the other two nodes I have in my case. So I run this a few times. If I get this to be a little bit different, there we go. Now, these are just off by just a tiny bit, but you can see that in SQL 1, this is my latest LSN here, and we are, in fact, lined up with neither of these, but we do have a later LSN. In this case, SQL 3 is actually the one that has the freshest LSN. Now, we're only looking at a fraction of a second here, but let me just be real mean. I may be screwing up a demo. I'm just going to turn off. All right. It's going to get a little. I could have also turned on a firewall. That would have been smarter. Yeah, would have been a lot smarter. Now it's going to do a 30-second timeout. Well, anyway, I was going to show you. I had to turn on the firewall actually. But hopefully we didn't lose that. Essentially, you'll get these scripts. You can run that. That would be your preferred fail on the target. Yeah, it didn't like that. The turning off was for another demo. Actually, I had a firewall rule set there to block my endpoint. That's what I meant to do. Because I wanted to show a little bigger gap between two things. You get the idea, right? Relays LSN, that's kind of the idea behind finding the one you want to go after. All right. Now let's stop this workload. And we have to talk through some. About 20 minutes left. So I'm going to talk through some, common issues around troubleshooting. All right, so common, probably this makes up maybe, I would say failover makes up about, unexplained failover makes up about 50, 60% of the cases that come in on AG. People don't know failed over for some reason, right? We've talked about this before. We had something happen. Where do we go to look for this stuff? I would say those top three are the most common ones. So some issue with your core for some reason, that would just be a machine went down. But also least timeout and health check timeout. Those are the two big ones. Least timeout is going to encapsulate all of your networking problems that might occur. And health check timeout is that SQL Server diagnostic has that with 5 varying levels of health check that can either pass or fail. Now, what are some common reasons for not failing over in this case? We have this, you're trying to fail it over, it won't fail over, or whatever, but we have either one or more databases are not synced. This is a common one. This is probably the most common one. People are trying to fail over an availability group, but for some reason the databases within them got out of sync. I'm going to give you a set of scripts to kind of look at that, see which database is currently experiencing problems. So it has a slowly draining queue, in other words. The secondary is not connected, and a few other different things. So from an architecture standpoint, we require and depend on Windows Server failover cluster, and you're going to have to at least be familiar with how that works, how to generate a cluster log. You might generate a cluster log, look through a cluster log, right? There's 3 pieces when we look at our RCA. If we come in with an AG case, this is the first 3 things we do. We look at not only always on SQL Server logs, but also the cluster logs. Let's talk about how we correlate the 3 of those together. So our root cause analysis works like this. The first thing we do is we get always on extended events. Has anybody seen those? Looked at them? Yeah, that's a new one. A lot of people don't know that. That's a black box for AGs. When you start up an availability group, you have an extended event running all the time. It's a big old mashup of XML. I have scripts to actually populate that out into a table. I've done that already for my AGs. I'll show you a little bit how that works. You have that today to look at. You also have SQL Server error logs and cluster logs, and you also have the SQL diag. So again, another black box that runs all the time. I'll show you where it is in a minute. So there's 2 different X events that are going to be system health runs all the time, and availability group health runs all the time. All right, so those are going to be the big ones. Then you can also look at the system health extended event, which is that other black box. SQL diagnostic extended events with SQL diag, that's another kind of piece. Application event, so on. Cluster event logs. That's different from cluster logs. So an event, DSP where you will have a cluster event log. That's different. Cluster logs are going to have a lot more information about connections and so forth. All right. Always on health XEL files. These exist out in your log directory. It's not your log file directory, but where your error logs are. Anything with an underscore XEL, there's going to be 2 of them there today. Well, when you start up SQL Server, there will be a system health XEL. Always on health XEL. And I have a script that will actually shred these out into a table for you, and you can look and see. First thing I want to look for when I'm looking at health events, I just want to look at my timing. What failed when, where. And so we'll have always on health, we'll throw up the quality file, and the max size can be 100 megabytes. So you'll have a lot of history what happened to the AG. I bet you on a normal AG, you're going to go back months. But I'll look at timing of when this occurred. And I'm just trying to build the case for what happened. And then I want to look for things like, this is another table we'll shred out to lead time out of it. We only store the GLID for that, but you can match that GLID back to DSP side, see what the AG name is, with the AG ID. But I will look for lead time out of it and any failover events. Those are 2 big things, like I talked about, common case issues that come in. All right. Then there's another table we'll get out of that, state changes. So again, we're kind of just building the case for our timeline. An important consideration here, is I want to correlate the 3 of those together. So I have at the top there my availability XDL file, extended event. And then I have my SQL error log, but importantly, I have my cluster log, and I'll show you how to generate those. Cluster log is different because it stores all the time events in UTC. So you'll have to think about your offset from your current time zone in order to do that. But once you get your timing, what we do, we look for our timing, the exact same timing for the flow down to the cluster log, and we start to get all the events.
Network errors, contact with failure cluster, whatever. These 3 pieces almost always we get us started in the right direction. A little bit on how the cluster log is organized. Here at the top right hand bubble, we can click on that. That's the full data again. This is a big deal on how it's built up, various cluster areas you might encounter. But from a very simple standpoint, we have 5 columns. The ones you care about are timestamp and message. So we break those down and shred this out. Generate cluster logs, hire SQL for what is done called cluster /log command, which then will put the log out to receive Windows for the log. It's kind of a pain. If you're using 2012 or newer, you get cluster log and pass the destination parameter, and it will push the cluster log down to your local directory wherever you are. I did some quick for you for both log. Now, this next slide, we're not going to go through all this, we don't have to. This is part of the email that I sent out to customers. Hey, what's the benefit here? What should you monitor? This is part of that. I have a couple slides on this, but this doesn't by any means encapsulate every single encounter, but set yourself up for success. They each want to monitor log queues. So all of your queues are encapsulated in these counters, and what they are slides, but capture things like understand what the log send is. Okay, where's the log sending happening? That happens on a primary replica. That's queuing line. Log send queue can be network problems, antivirus, firewall, whatever. Log like plug and so on for database level. Descriptions are around each one of these, each counting down. I gave you those for the resources. Other things about capturing network problems, local control time, and so on, what that means. And then that last piece, why am I not seeing this? I'm seeing it on the primary, but I'm seeing it on the secondary. We do bites rating, we do all that. Those are four things. I know I went pretty quickly to that troubleshooting piece, but I really put those slides there for the reference. A lot of helpful notes, including takeaway. Because I want to just look at notes here. Of course.
Could you cover, we have a failure, and we must be secondary, which is
Yeah, we did. Yeah, so yeah, you have to manually, there's that process where it will, you have to manually resume data movement, bring it up manually, set the data loss. You have to join that previous primary back up if it's LSN is newer, then it doesn't roll back. It starts with- Right. So a couple things I want here at the end. Always on extended events. So all that stuff we were talking about, all those logs, let's please. The files, I think I gave the first one. Let's look at that together. So these two are going to be one of them now. Shred AO help. All these XML files, tables for you. All the time. Look at the log record. See program files, server, sort by. I can see these. Some of the old black box tricks. Pass through the path to use help. Takes a little bit of time. So this is from yesterday. I was kind of messing around with this. But you can see each one of the things you kind of went off or whatever, but you have all the different areas that might have occurred. Keep that area right in there. You have various state changes like I was talking about. Offline, many things are online. Really, the point here is to correlate those state changes back to stuff that's happening along whatever. It's just running all the time. There's no black box. Here's another cool one about added. You have read blocking. So you can actually block on your secondaries. If you put DDL through on the primary, we actually want add a column or something. And you have to put that DDL through when someone's holding a block on the secondary. Well, that's what's called read blocking. Because they maybe have, they're holding a lock on the secondary table, schema lock at least, share schema lock that doesn't allow you to make that table change. So you could say there are ways to disconnect that, and that was not something I really should talk about that a little bit. But read blocking is a common problem as well. You have people putting long connections up on their secondaries. You can actually have them just by doing a select on the table and your transaction up and cost you to kill it. There are ways to manage that. But this is all stored here. All this is documented in the script I gave. The other thing is the system health section, which sadly I stored in the database that I deleted right at the beginning of the demo. So we'll see how long it's going to take to import. Let's start. Oh, I actually still have some stuff up here. So the final piece is this get cluster log destination. So I have the ability to view pull all my cluster logs down, but to that, it's going to pull everything in public for me. Okay. cluster log here, my directory. Then the last thing I want to show you is something I just discovered myself. It's why I wanted to encourage people to get this version of the video. I'm on 17.5 here, this came out 17.4 December. If you look at, everybody's seen the dashboard, right? You know, usually if you see the dashboard, this is probably new to you. It was to me. This little button right here. Have I seen this one? Select latency data. So I actually have a script in here for you to do this manually. What this does, it's really cool. It will instantiate a single agent job, 5-part single agent job on every replica. It will start a custom extended event, stop at a custom extended event, based off whatever time you want, like 1 events. Shred those events into the table, and then you can right-click and build in managed security reports. That is a really cool thing discovered here recently. If you look at scripts, we would have had to do all this manually before. Log one lifecycle. So essentially, this gives you everything that's log one lifecycle and automatic way to do it. So it'll deploy out these extended events, each one, collect back the local table, reports, which data collection starts. You can see I started some data collection there. And so it's running all 3 servers, everything in there. That's kind of a cool one. And you'll get nice reports. If you right click on the AG reports. Primary reference to latency, secondary reference to latency. Get some nice graphical reports, but more importantly, all this stuff is persistent. That's linked up. You know how many times, how long, microseconds in this case, the event committed and so forth. Server, but you can see various information around events we had, press using what people have sent to you. So pretty cool. Hopefully, kind of the last piece here, hands-on labs and always on codes log, kind of where I go, all this stuff I'm talking about things there first. The hands-on labs will, as of today, it's built in 2014, it's being updated in 2017. So if you want to kind of a playground for a couple hours to mess around, or play something new, you don't have dev boxes, and you get 2 hours of 4 VMs, DC and 3 single nodes. So it's linked on there. Yeah, that's about it. Hopefully it's useful. I know that talking about AGs for an hour and a half, you know, we can talk about what it seems quite a bit more time. I did a 4-day workshop, or I did a 4-day workshop on this. So I know there's a lot of things in here. I hope that it was informative. Yeah. Any questions?
This is being recorded. We'll upload it to the archive page on our website, and I'll get the slides.
And if you want to get the slides for yourself right now, they're right here. And all the script.